Hello everybody, my name is Yakov Fain, and today we'll talk about Angular. First of all, a couple of words about myself. Actually, I'm a Java developer for many years, and over the last 2 years I work with Angular 2 in particular. It started when we wanted to migrate our projects from Adobe Flex, if anybody knows, to JavaScript, and we couldn't find anything that is even close in terms of productivity to Adobe Flex. So finally, it seems like we found a framework, which is Angular 2 and TypeScript. Recently, we published a book, and down there's a promo code if you want to get it at Manning at a discount of 40%. So what do we talk about today? Today, I'll start with explaining the basic of reactive programming and Rx JavaScript. And then we'll switch to Angular and see how Angular is using these constructs. So RxJS, in particular RxJS 5, the latest version of reactive extensions library, by the way, it's written in TypeScript as well, is integrated into Angular 2. When I say integrated, I mean it comes with it. And Angular 2 uses it everywhere. It's a library. In general, there are multiple versions of reactive extensions libraries for different languages. It started back in 2011, I believe, in Microsoft, and they created Rx.net, and it became popular, and it was migrated to all languages, including Java and Python and PHP and you name it, Swift, everywhere. So the good part about Rx extensions library is that you don't have to change the way you program. If you think that you want to use some reactive construct at this particular place, you use it here and only in this place. It's not changing the way you program. You add a library and you use it. Let's talk about the main players, so to speak, or main classes, main functions in Rx. And the good part is that if you learn Rx principles in any language, you can easily switch to a different language, and Rx will be very, very similar over there. The names of the classes may be a little different, but the principles are the same. So observable. What is observable? It's a data stream that comes at you. The data that are pushed to you over time. Time is an important part over here. One element, next element, next element. And your program reacts to it. So observable is the class or a function, depending on the language, that will push data to you. Observer is a class or a function that knows what to do with the data. Observable sends the data, and observer handles the data. Subscriber. Subscriber is something that brings together observable and observer. So until somebody subscribes to the data, you may not get any data. Subject. Subject, it's a combination. I know this is a Java conference, so I'm sure many of you used to work with JMS, for example, pub/sub concept, right? So you can have a topic over there, and you can publish the data to the topic and subscribe at the same time. So subject is a similar construct. You can publish as well as subscribe to. Operator. This is where the power of Rx libraries is. As the data is moving to you, you can handle the data en route. You can write a bunch of separate functions, and you can chain them together. And the data is moving, and it goes through these functions, which are called operator, until it'll reach a subscriber. And we'll see how this works. Let me show you a simple example so you can relate to it. Say you have some machine, a printing machine, that prints magazines. And somebody delivers to you these magazines. Who is this somebody? It's an observable. Every item delivered to you by an observable, in this case, let's say it's a women's magazine. So one item. next item, next item. Observable is pushing data to you. And there is this couple, Brad Pitt and Angelina Jolie. Brad Pitt has money to subscribe to magazines, right? But Brad Pitt doesn't need women's magazines. On the other hand, Angelina Jolie has no money to subscribe, right? But she knows what to do with this magazine. So Brad Pitt, in this case, is a subscriber who brings together observable and observer. When observable delivers you the next item, it can invoke one of three methods on the observer. Next, when the next item comes in, error, if something happened, or complete, when the stream is over. Very simple API. So observable can emit the next item, signal the error, or signal the end of stream. And also observable allows to subscribe, unsubscribe to its data, whatever it is. Accordingly, an observer needs to know how to do three things. What to do when the data comes in, what to do if an error happens, and what to do if the end of stream is coming in. How to create observables. There's a whole bunch of APIs, and you can read documentation, but on this slide I put a bunch of methods that you can use. I want to remind you, at this point I'm talking about JavaScript. If you're interested in Java, there is RxJava and your version RxJava 2. You will find there similar constructs. So you can say observable.create and provide an observer, an object that knows what to do with the data. Or you can say, I have an array or an iterable. Turn it into observable, so it starts pushing the data. Because if you just work with an array or with iterable, you would need to pull the data, right? You would need to do for each, for example. But in this case, we want the data to be pushed at you. From event, when we develop UI, there are different events that may be happening in the browser, in your app. You click on the button, and you can subscribe to these clicks. A click is the next item. You drag the button over the screen. Each coordinate of the mouse pointer is the next item. It's a stream. So you need to start thinking that everything technically is a stream. Even one click, it's a stream of one item. If you work with promises, you can have a promise and turn it into observable. If you want to just generate the data stream of some numbers from 1 to 10, for example, you would use observable.range and specify the range. So there are different ways of creating observables. Now let's talk about operators. As I said, when the data moving in, you can attach a bunch of operators to it, so they will transform the data. So the subscriber will not get the source data, but transformed data, or maybe filtered data. Are you guys Java developers or no? Who knows Java? Please raise your hand. All right, everybody, pretty much. So if you know Java streams, you know the concept, right? When you work with a stream, you have all these intermediate functions that you can chain one after the other. But if we talk about Java streams, you have very, very limited number of functions that comes with it, like map, filter, of course. But in Rx libraries, there's like more than 100 operators available to you already, out of the box. So what is an operator? It's a function. An important part is how it handles the data. Very simple API. It takes an observable in as an argument. It does its transformation, and it returns another observable out. So since every operator has this API, you can chain them together, like pieces of a pipe. Let's take an example with beers. Say you have an array of beers over here. Beer objects, several of them, and you want to turn it into observable and push it to the consumer. So on this slide, you see an example of observable beers. Say we turned it already into the stream. Like I can do observable from and specify an array, right? So I'm going to get an observable. After that, I can start attaching different operators. In this example, I'm using the filter operator, filter. I don't want to see all beers. I want to see only those beers that have price less than $8. So how filter works in this case? If you look at it in green color, you see a function. So like a lambda. ECMAScript 6 supports lambda. TypeScript supports lambdas. And so it's an anonymous function. I'm talking about this green part. We are saying, take the next element. I decided to call it beer. Then it goes fat arrow. In Java, you would put dash and greater than. In JavaScript or TypeScript, equal sign. And basically it's a predicate, the green line. You're saying, return me true or false, depending on if this expression is true or false. So every element will go through this filter. And only those objects that meet the criteria, meaning less than $8, will be passed forward. Subscriber will go after. If it's more than 8, subscriber will not even get this object. So it's like we handle it lazily. Filter. So filter is a function, right? And the green lambda is a function. So what do we say? We say it's an example of higher order function. Filter is a higher order function. Why? Because higher order functions are those that can take another function as an argument and can return a function. So green is also a function. Typically, we use pure functions. What is a pure function? A function that always gives you the same result if you provide the same arguments, always. Like in this example. First of all, we are just checking the price. We don't try to evaluate any external parameters. It's not like an object with some member variables which may be changing. No. Everything is inside. We don't change the environment. We don't reach out to get some data from the environment. Pure function. Now let's take a look at this example. So I create an observable beers, rx.observable from, and I provide an array. Then I attach the filter function, and then I attach the map function. All of them are from this Rx library, of course. Filter, as I said, is filtering. And then map is always converting an object from one type to the other. Maybe you had an object with 20 properties, you want only 2 of them, or you want to convert it into a string, whatever. Map is about conversion. In this case, I'm taking an object of type beer, and I concatenate the name of the beer with a $sign and with a price. I turn it into a string. The next line says subscribe. Remember I said in the beginning, what do we provide to a subscriber? An observer, right? Something that knows what to do with the data. And what observer can do? It can provide the handling for the data. It can provide the handling for the error. It can provide the handling for the end of stream. And we have 3 lambdas. First function is what to do if the data comes in. Second, what to do if the error comes in. By the way, you're going to get an error object in this case. And third, what to do if the end of stream comes in. What is very important in this code? It is important that when you declare an observable, the first part, no data is moving at all. It's your intention. You are saying, I'm declaring that I'm going to get an observable from an array of beers, and I am planning to filter it out and map the object. But nothing is happening yet. Till when? Till a subscriber exists. Till there is something that is interested in data. So until you do subscribe, no data will be moving. There is a concept called called observables. And for the most part of this presentation, I'm using called observables. Called means until there is a subscriber, no data is produced. So in this case, the minute you set subscribe, you start getting data from that array pushed at the subscriber. In some slides in Rx, I have plunkers with the links. By the way, the last slide will have a link to this presentation, so you can download it later and try it out. It's just a short presentation. Usually I spend like an hour and a half for this. So I can't run these plunkers, but you will be able to do this. When you will be reading documentation about Rx, you will run into some situations when documentation is not that great, especially for the latest versions. So what you can do two things. One, you can read documentation on Rx in any other language. The concepts are the same. And two, you can use so-called marble diagrams. The diagrams, in some cases, is more explanatory than the text. This is an example. All Rx libraries will have these marble diagrams. So when you look at something like this is how they describe a map function as a marble diagram. Always, you will have a stream, incoming stream, and outgoing stream. So the line on top represents the time moving from left to right. So let's say you have a stream of circles. Every circle comes one after the other over some intervals. And we have a function map. What does it mean, this picture, this diagram? I see that inside the map, they take a circle and they turn it into a diamond, right? So for me, it tells that I'm going to get a stream of circles, and as an output, I will produce down there another stream of diamonds. When you see a vertical bar on this diagram, it means end of stream. If they want to represent what to do in case of error, you will see a little red cross on the line. So from this, I can understand that every element from the stream will be converted, and I will get another element as an output stream. Filter function. This is a marble diagram for the filter function. How it works. Let's try to guess. What do we get on top? We get a stream of different shapes, right? When I look at the filter, I see a circle over there, which tells me I am probably filtering circles. I want to get only circles. So how many circles are there on the incoming stream? Only 2, right? So as an output, I'll get 2 circles only. If you look at the brewery process, I can relate to it, to this idea of taking the data and moving through your algorithm of your program. So if you look at the beer brewery process, there are multiple stations, and the beer is flowing over each of the stations, right? So in our terminology, you can think of it this way. So the beer is an observable flowing through the algorithm. And you have multiple operators. Every operator will do something to the stream of data, to the beer. If you decide to unplug one of the functions, it'll still work. You know, sometimes you can buy unfiltered beer, right? So take out the filtering operation, and the process is still going on, but you have one operation less. The whole idea is that you build composable small functions, small operators, and you can compose the whole thing using these functions chained with each other. What do you do with an error? If you'll go to reactive programming, there is something called Reactive Manifesto. You will read there all these declarations, and one of them says that your reactive system should be resilient. Meaning what? Meaning if an error happened, it should be able to recover so the user can keep using the system. So how to do this? We want to be able to intercept an error, handle it, and move on, instead of just saying that error happened. It's not about throwing exceptions, especially in distributed system. You don't know where it's being thrown, how to send it over. You always have a dedicated channel for sending errors. But if a subscriber will receive an error, the stream is over. Any stream can be finished in one of 2 cases. 1, an error happened. 2, an end of stream arrived. But it's too late. The subscriber is dead. So what we can do, we can intercept it. There is a, for example, there is an operator catch. If you will, again, you change them up. If you will put catch before the subscribe, the error will jump right in the catch statement, and inside that catch you can check, oh, if it's an error 500, let me try to resubscribe to a different data source, alternative one, failover. Or if it's an error 404, do something else. So you have a chance to intercept an error and do something so the data flow continues. Or retry. You try to get the data from a stream is not ready yet. Maybe you want to retry 2 seconds later. You can do that. Or retry when. You can write a function that describe your logic, your business logic, saying when you want to retry. And here's an example of a failover with catch. Look at this. Say I have 3 functions, 3 data sources. The primary data source, the function getData, returns an observable. If something goes wrong with this data source, I have another one. Get cached data. Maybe I have data in the cache. Or I may have another function, get data from another source. Each of these sources will return me an observable. Ideally, if everything is great, I want to get data from the first function. So what do I say? Get data dot catch. See, catch operator, and then map operator, and only after subscribe. So if error happens in the function getData for some reason, then I'll go into this function catch, and I can take this error in my hands and decide what to do with it. Like in this case, if an error status is 500, I print it on the console, and I return get cache data. Get cache data also return an observable, right? So I still have an observable, a different one, but I'm alive. I'm not dead. Or in this case, or otherwise, I will return get data from another source. Get data from another source. Maybe it'll connect to a different server and get the data from there. So the point is, I will not, the subscriber will keep receiving the data. Why? Because I intercept them before they reach subscribe. Subscriber will see the data. It may not know that they are coming from cache or they are coming from another data source, but the whole point is that the system stays alive. FlatMap. It's a very powerful operator. Not so much in JavaScript, I'd say, but in Java it's super powerful. But let me explain it first in JavaScript. So flatMap is for cases when every item that you are getting is an observable is in turn an observable. So you may have an item, the data piece coming in, but internally it has some other data. So you want to subscribe to that one as well. So instead of writing nested subscribe, you say subscribe, give me a big piece, and flatMap will automatically subscribe for the internal of the items and will flatten it up. Like in this case, I'm getting a circle, but actually it's not just a circle. Inside that circle, we have something else, another observable. As an output, you will get every item from the internal observable as if it's only one, I'll show you an example. Again, it's JavaScript in this case. Say we have one observable beers and the other observable soft drinks. These two are different arrays. And I want to push to the subscriber first beers as one item, which internally has 3 beers, right? And second, I want to push soft drinks. So what do we get? So what I say, return observable create. And I'm saying, give to the observer, one time I call next, I am pushing the data. In this case, I am pushing beers. And then I'm pushing soft drinks. To whom? To the observer. Whenever somebody will subscribe to my observable stream, they will give me an observer. They will give me an object that knows what to do with the data, right? So observable always calls next function on the observer. Next, next, next. And observer knows what to do with the data. So what I do here, I am pushing one observable and another observable. One and the other. So inside the, So what can I do? Since getDrink returns observable, what can I say? I can say getDrink.flatMap. I'm saying flatten out everything that you're getting. Every item will have inside some other item. Resubscribe, and just give me single items. So I just saying flatMap and then subscribe. So in the console, if you will run this plunker, you will see Stella, Sam Adams, Bud Light, Coca-Cola, Fanta, lemonade. Single items. Why it's super powerful in Java, for example. Java has additional feature which allows you to use so-called schedulers. You can assign a thread to each item. So you can do multi-threading. So you can say flatMap and assign a separate thread for each item. Boom, it goes in parallel. Very powerful thing. Again, in JavaScript it's not so powerful, but it's very convenient because you don't need to write nested subscriptions. Look at this. So many operators are there. Many, many, many of them. It's out of the box. Of course, you can write your own operators, but there's tons of them coming with Rx library, with any Rx library. And now let's switch to the Angular framework. Observables in Angular. From the very beginning, they decided, Angular creators, that we will be using observable in multiple places. First of all, forms. When the user fill out the form, you want to know if the form is valid or if it's not valid. When the user types in the data in the input field, you want to get the data. All these things are created in Angular as observables. For example, every field on the form, so-called FormControl object, has a property called value changes. It's already an observable. Angular did it for you. So what you can do, subscribe. You have an observable, subscribe to it. So the user will be typing, and you will be getting items as he types or she types. The form is not valid. You may attach a bunch of validators to a form in Angular. Some of them are gives a problem, saying, for example, social security number field is supposed to have 9 digits, but it doesn't. So the form isn't valid. There's a property called status change. And you can subscribe to it. What does it mean? It means whenever it changes, you're going to get a new item. Initially, it was invalid. Now it is valid. So you can catch all these moments, and you can react to it. And now let me show you a little demo. Say we have a simple code. This is a component in Angular. I assume that you know some basics of Angular. So every component is a class with an annotation at component. The annotation at component describes the UI. In this case, we are using HTML header to observable events and input field, HTML input field, where I'm saying enter stock, and I am binding. These brackets means binding in Angular. This FormControl directive to the variable search input. What is search input? It's a variable that I declared in my class. It's of type FormControl, and I created an instance of it. So now the instance of FormControl object is mapped to the input field, this particular one. And since if you read documentation, you will see that FormControl has a property value changes, which is an observable. If it's an observable, what you can do? Subscribe to it. What else you can do? You can attach a bunch of operators before the subscriber gets the data. So what do I do here? I'm saying this.searchInput.value changes, observable, and I could write subscribe right there. But now I am attaching an operator. In this case, the name of the operator is debounce time, one of the 100 operators that comes with Rx. What is debounce time? Imagine a situation when you type something in Google field, in the text field, and as you type, it brings you some data, right? What if you don't want this to happen? What if you don't want to initiate an HTTP request for every little character that you typed in? So you can use debounce. Debounce time means unless, in this case, 500, unless the user will not type anything for 500 milliseconds, don't even push the data. Only if there is an interval for 500 milliseconds, only then push the data. So we will not be sending too many, for example, HTTP requests. And then you say subscribe. When the data comes in, what is the data? Whatever the user typed in that input field, right? What do? I say get stock quote from the server, and I pass this value, whatever user entered on the UI. In this case, I am just using a random number generator, so I don't go to any server. But the point is that subscriber will initiate the call for get stock quote from the server for every item that is pushed by observable from the UI. Let's run this example. I'm using WebStorm. Again, for being a Java developer, IntelliJ IDEA you can use WebStorm. There is an excellent free editor from Microsoft called Visual Studio Code. All of them have great support of TypeScript, so I do recommend you use whatever you like. I'm using the latest version of Angular. By the way, on Thursday they are releasing version 4, so I'm using it. It's not a major rewrite, it's just improvements here and there. So what do I do now? I want to run this example. To run this example, I have a couple of applications in this project. So what do? I need to say inside this project, inside this Angular CLI.json special property, what do I want to run? Actually, this is not the right project. Let me do this one. What do I want to run? I want to run the example called main from control or form control.
Yakov?
Yes.
Can you go to presentation mode?
I prefer to make the font larger, like this.
Thanks.
All right. So I want to run this example, and I have this main form control, and over here I have this code, very simple code that you saw on the slide, basically. If I will open it up, you will see the same exact code that you saw on the slide. Now, what I will do, I will build the bundles. I will build the bundles in memory. I generated this project using a special tool called Angular CLI, and it comes with Webpack. And for deployment, it generates the application into bundles, so you have less files to deploy. Right now, I am in dev mode, so I'm generating the bundles in memory. So this part is ready. So if I'll go to localhost 4200 default port, I will see my app up and running. Let me open up the Chrome Dev Tools down there, the console. So if I will start typing, see, I was typing pretty fast. If I will make a pause for 500 milliseconds, you will see how it's going to work. See, it was pushing the data twice in this case. Why? Because I put debounce time 500 milliseconds. I was typing slow. So that's why it gave me AA and then another item. Again, if behind the scenes I would be making a request to the server, I would be making 2 requests, and you will see that in a moment. Now let's take a look at another example. HTTP. Of course, we want to handle HTTP requests. HTTPs in Angular, by default, return an observable. Every HTTP request. If you are more familiar with promises, you can stick to promises and take the observable and do 2 promise. But I don't see a reason for that. So let's take a look at this example. Say I have a server somewhere. In this case, I have an app component, and in the constructor, I specify that I need an HTTP object. In Angular, there is something called dependency injection. As a matter of fact, if there is somebody in the audience who is not familiar with Angular 2, who wanted an overview, tomorrow afternoon I will be doing a presentation on Angular 2 for Java developers. Over there, I'll give like a big picture of the framework. So in this case, so this is dependency injection. I just declared an argument of type HTTP. Angular will inject for me an object HTTP. So HTTP supports all these get, post, put, delete, all that. So let's say I have somewhere an endpoint product. So I'm saying this HTTP.get product. So what is interesting, if I will forget to write subscribe, no data is moving. It looks to you like as if I'm making HTTP GET, but I'm not. If there wouldn't be subscribers, the data wouldn't be moving. But in this case, I'm saying go and get for me the data mapped to the endpoint products. And then when the result comes back, what comes back? HTTP response. Extract from there JSON. This is my map function. And give me back the JavaScript object. And subscribe, I provide 3 things. Remember, for observer. What to do when the data comes in, what to do when the error comes in, and what to do if the end of stream comes in. Now, in the previous slide, I was using subscribe, right? But Angular has something called pipes. And if you will look at this one, this vertical bar is a pipe. And there is a special pipe called async. Async pipe is smart enough to automatically subscribe for you. Async pipe you can use in templates, in HTML. So what I'm saying here, let me explain you this example real quick. Basically the same thing that I did on the previous slide. Get the product, give me the JSON. And what do I do with the JSON? What do I want to do with the JSON? I'm saying I have product, right? So this get will extract JSON, turn it into JavaScript object, assign it to products. Inside the template, Angular has this special directive ng4. It's like a loop. I'm saying declare a variable product and loop through the array of products right there. And since I put pipe async, I already subscribed to it. So what happens is this li element, it's an order list, right, HTML. This li element will be repeated as many times as I have in the products observable. So I'm going to get all the, in this case, I care to show only the product title. Pretty simple, but it's a subscription. And now a really, really, really powerful operator, switch map. You don't think about it unless you have it. Switch map operator. When you make a request to the server, your app makes a request. What if the connection is slow? Say as a user standing with the mobile phone on a slow area connection, type something in, I want to find the price for the stock or maybe something else. Click on the button, the request goes out. The connection is slow. I am annoyed. I don't want to wait so much. I keep typing something else. Another request goes out, right? Question, what happened with the first request? It still is up and running. At some point, it is going to come back. You have the low bandwidth already on the network. And by sending more and more requests, you're making the situation even worse, right? So what happens is this switch map allows you to automatically kill unhandled responses. So the user types something in, boom, it goes out. It didn't come back yet, but the user produces something else. If that guy didn't return, it's going to be killed automatically. This is super powerful thing, especially if you care about performance of your web apps. If you think that this diagram is not easy to understand, believe me, if you read the documentation on switch map, it's even worse. So let me explain you what it means. They are saying there is a stream, right? Red circle, green circle, and sometime later this blue circle comes in. Switch map is in a way similar to flatMap. It knows that there is something inside every element. And let's see, there is this red circle, right? Switch map operator knows how to convert this red circle into this sequence, diamond and a square. So it produced red diamond and red square, fine. The next element comes in. It needs to produce diamond and green square, green diamond and green square. But all of a sudden, this processing is not finished yet with the green, right? But the blue item comes in. So you will never see in the output the green square. It's going to be killed. So switch map is switching over to the internal observable if the new element comes from outside. So this, the top line, we can say it's an outer observable, and these little guys are inner observable. It's still like Chinese, I'm sure, whatever I said, but I will show you the code and you will understand and appreciate it. Look at this code. And I will run this example. This entire example is about getting the weather in a particular city. There, I found somewhere a public server that reports a weather, public API. This is a URL of that server. You just need to take this URL, attach the name of the city, and attach the application ID. You apply for it, like it takes you like a minute or not more. That's my app ID that I got. So what do I have here? I have an HTML with an input type, right? And I can type, the placeholder is enter city. I can enter the name of the city. And what do? Again, same story. I said that this is the form control. I created a variable search input, and I bound it to the form control. So immediately I get this value changes property, which is an observable, and I can subscribe to it. So in this case, what do I say? I say the bounce time 200, unless the user is typing fast. If there is an interval of 200 milliseconds, send it out. Send out what? Whatever I managed to type in the field. And then I say switch map. Switch map means switch over from an outer observable, in my case typings in the input field, to the inner one. What is an inner one in this case? So see what I'm doing. I say this dot get weather, and I'm passing city. City is whatever I enter in the input field, and I'm giving it to a function get weather. Get weather is right there. Get weather supposed to, not supposed to. It returns HTTP get. I concatenate the URL of the server plus the city that I had typed in plus the suffix. And then I say I want to map it. Response, I want to extract JSON from it. And also I am applying catch, right? So what if I want to get the weather in San Jose? And I manage to enter only S. It goes out, there is no such a city, S, right? So I'm going to get 404. If I wouldn't be doing processing, error processing, if I wouldn't intercept it, my stream would be over. It would be killed. But what I'm saying, no. If you got 404, just return me an observable of nothing, empty. So I'm still getting an observable. So the subscriber is happy. It didn't get anything, but it's not an error. So now, what do we say? Again, I want to stress, when you look at the function getWeather, you may get an impression based on your experience with other programming languages that this function makes an HTTP request. It makes it only when I write subscribe. If I wouldn't write subscribe, it's just a declaration of intention. This HTTP get is not get. I'm just saying whenever a subscriber comes in, I will do get. Right? So what do I say here? Get the data from the UI, pass it over to the getWeather inner observable, right? And then subscribe. But what happens is, if the connection is slow, if switch map started getWeather didn't return me anything back yet, but the new things comes in, user keeps typing, the previous request will be killed. And I'll show it to you in action. So we'll go back to the IDE. Let me kill this guy. And in the AngularCLI.json, I want to say that I want to run another application now. In this case, it's called main HTTP. Save. I'll show you the code, but it's basically the same as you saw on the slide. I'm rebuilding bundles in memory again. The code is located here in the HTTP. As you can see, it's the same thing. I have this getWeather, and I have switch map. Everything is like that. So the bundles are built, and let me go here. So localhost 4200 enter city. So I will start typing the name of the city. And what I want you to see, I click on the network tab. Let me clean it up for you. And you, as I type, you will see how many requests will go out for that weather server. Let me do this. Look at this. I just entered San Jose, right? And since I was a slow typer, I had this interval of 200 milliseconds. Remember the bounce time? It went out, and it's, look at this. This request was for SA, I got 404. Then SAN, maybe there is something SAN. SAN space JO, and so on. So it went out, and it returns me tons of data, which I don't need actually. I need only the last one. Luckily, I am on the fast connection now, right? But think about it. What if I would be on the slow connection? How many requests would go out? Now, let me show you this. I will emulate a slow connection now. In Chrome DevTools, there is this little thing called throttling. I click over here, and I say, emulate for me a slow connection, 50 kilobit per second. Let me do it, and I will do it now. I will enter a different city, New York, for example. Look at that. See those canceled? As I was typing, requests were going out, but connection is slow. They were not handled yet. So now look at this. It's much better, right? 0 bytes return. So it didn't take my bandwidth. Automatically killed. Just for that, you need to use Rx and switch map in particular. Okay, let me wrap it up. We don't have much time. In the router, Angular is about single-page application, right? So you have an area inside the application, and you have routes. User click on this or that link, and certain fragment of the page is changing. We are rendering different components. Router does it. When you pass from one route, when you go from one route to the other, you may need to pass data. Say you show products, you click on the products, you want to show product detail, which is a different route, different component. You want to pass the product ID, right? Which one you want to see the details for. So router has also observables internally, and when the router object, activated route actually is given to you, you can subscribe for changes. It's like master detail situation. A list of products, click, click, click on different products, and the details component shows you different things. Detail component subscribes to the data coming in from the router. And finally, types of observables. There are cold observable and there are hot observable. So far, what you saw was cold observable. Until there is a subscriber, the data is not produced. So, versus hot observable. Hot observables pushes the data regardless if there is a subscriber or no. Think about it. You may have a phone with accelerometer. You're moving with the phone, and accelerometer is sending like 50 signals a second with information, regardless if you run an application that handles it or not. It pushes it. Or Wall Street server pushes the stock prices. It'll push the stock prices regardless if there is anyone who subscribes to it or not. It's like a broadcasting. You turn on the radio. I mean, the radio station broadcasts stuff. Regardless, it doesn't know if anybody is listening to it or no. Whereas cold subobservables needs to have a subscriber. So on this slide, I show you how easy it is to have an observable in Angular, actually in Rx as well, and share an observable with multiple subscribers. Subject, remember I said subject is at the same time observer and observable. If you will create this subject and say share, you're saying I want to have the same stream, but I want to have different process or different subscribers, which may be doing different things with the data. Like in this case, I have an input field, I want to handle input event and key up events, right? So in key up event, I want to print the symbol that user typed in on the keyboard. On the input event, I want to display the data. So I say, I want to create a new subject, I want to share it. Share with whom? With as many subscribers as need be. The first subscriber is here. It'll be handling the keyboard events. The second one will be handling input events. And they both use the same stream, the same producer, so to speak. All right, I don't have much time, but in Angular, you also have event emitter that is a subject, technically. And the final slide that I show you is how you can easily maintain state in Angular application. Imagine that you have multiple components, and you have some important information that stores the state of your application. So what you can do, You can inject this service in Angular, inject into multiple components. For example, component number 5 needs can change the state variable, and component number 6 and 8 needs to know about it. So you can create a service, inject it into 5, 6, and 8, and 6 and 8 will subscribe to changes in the object. So I don't have much time left, so let me wrap it up. Write down the URL. The top URL has all these slides that you just saw, the presentation. Now, the code samples of the book. The book was published like 3 months ago, but we maintain GitHub site with a bunch of examples, and we keep adding new examples. And as the new versions of Angular comes in, we keep adding stuff there and updating it. And that's about it. Thank you very much.